Okay, so here's part 3. So I'm going to give the example that Lurie gave, and then I'm going to give a slightly different example to talk about where this clock arithmetic can help us. Okay. So he said we're going to try to solve this equation in the integers. Okay. So we're going to try to find one integer x so that x squared plus x plus 1 equals another integer y cubed minus y. So give me an x.
X would maybe be 2.
Okay, so if x was 2, we would have x squared is
4.
Plus 2.
6. 7.
So we're trying to find some integer y so that y cubed minus y equals 7. Well, maybe we would try 2 for y and get 8 minus 2, which is...
6.
Oh, shoot, so close. Maybe 3.
3,
We get 27 minus 3. Still a little too far away.
Too far away, and it looks like if we go to 4, we're going to get even farther away.
So we could try. Well, 1 would be 0.
Yeah, 1 would be 0.
So we can't work it for 2.
Doesn't seem like we could solve it for x equals 2. The problem with trying it now with all the integers is
You can't.
it's going to take a long time, right?
Yeah.
You would need an infinite amount of time to just even write down the infinite integers on this side, and then you would have to check infinitely many on this side for each one. So hopefully there's a better way.
Yeah.
And he says, I want to look at a clock that just has 2.
That would be like a base 2 clock.
Yeah, it'd be like a base 2 clock. So, in base 2, the numbers that end in 0 are special numbers. What are they called?
They're
even.
They're even.
They're the even numbers. And the numbers that end in a 1 in base 2 are
Odd.
odd. So he says, basically, by looking in base 2, or looking at a clock with just 2 values, let's just look at evens and odds. So, if this side, if x is an odd number, is this even or odd?
Well, an odd number squared is an odd number.
Okay, so we get odd plus
An odd,
Which is an even.
plus 1.
which is an odd number.
Okay, so if x is odd, this is odd. What about if x is even?
Well, we did.
Sorry, if x is odd down here. What about if x is even?
Well, we already did the example with 2. It's going to be odd.
If x is even, we get an even number plus an even number, which is
even.
plus 1, which is
Odd.
okay. So that's nice. This side, if x is even or if x is odd, this side's always odd. I keep saying it backwards. Sorry. If x is odd or x is even, this side's always odd.
But you wrote 2 zeros there.
Yeah,
It should be
because
odd.
if x is odd, we get an odd number, and if x is even, we get an odd number.
But the 1 represents the odds.
Oh. Thank you. Okay, so now what about this side?
That side, if you use an...
If I use an even number,
Well, you get an even number cubed. That's it's an
Even
cubed
number.
even number.
okay,
Minus an even number, which is an even number.
okay. I'm gonna write even. That's why I was writing odd, but yeah. Okay. What if I had an odd over here?
And odd, you would get an odd number minus an odd number, which is an even number.
Hey, so this side's always even.
And this side's always odd.
This side's always odd when
there's
we
no,
use integers.
There's no integer solution.
So right away, just from looking at our clock with 2 things, it tells us, hey, kind of surprised, there's no solutions. All right, you ready for a slightly different example of this?
All right.
Do it in a new movie.